Geometry brought to you by Diet Do. Okay, let's do the last section in this chapter, and it is on triangles and coordinate proofs. And all this really means, it sounds terrible, but all it really means is that you can take a triangle. Oh, you know what? Let me let's do just a right triangle. That'll be a little easier to explain. So let's say this is a 3, 4, 5 right triangle. Well, you can deal with that just floating in space like that, but it's easier mathematically if you could, superimpose that on a coordinate plane. That's what Rene Descartes, when he came up with the Cartesian plane system, that's the whole beauty of it, is that it allowed you to take something that was just floating in space, and it allowed you to manipulate it algebraically. So he put, of course, an x and a y axis, and we could just stick this triangle onto our coordinate plane here. So we go over 3, start at the origin, go over 3. This side we're going to go up 4, 1, 2, 3, 4. And then we connect those two. And so this triangle now is placed on a coordinate plane. And so we can deal with these different points. We know that this point is 0, 0. We know that this point is 3, 0. And we know that this point is 0, 4. And it's just handy to have it like that, okay? So that's the first thing they ask you to do is be able to place this on a coordinate plane. And then what they're going to ask you to do is to write different proofs based on this. And let's just do one just to practice. It's example 3, and it's on page 335. And give me a moment, and I will write down everything, and then I'll get right back to you, okay? So just relax. Okay, so here's the picture of what they want you to write a proof for. And what they say is that you have this triangle, A, B, C, and S and T are the midpoint bisectors. S is the midpoint bisector of this line segment, and T is the midpoint bisector of this line segment. And so what they ask you to prove is that line segment ST is parallel to AB. Okay? So here's the way we're going to do that. We're first going to figure out what the coordinate point of S is and the coordinate point of T is. And since you know that they're the midpoint, you go back to the midpoint formula, and if you remember, you just add together the two x's and divide them by 2, and you add together the two y's and you divide them by 2. So let's do S first here. So we have 2b plus 0. Let me just do it down here, and then I'll erase this. But it's going to be 2b plus 0. That's the two x's added together, divided by 2. And you can see with a little quick algebra, 2b divided by 2 just gives you b. So the x point is b. Let's do the same thing with the y's. We have 0 and we have 2c. So 2c plus 0 divided by 2. You're going to do the exact same thing, and you're going to get the y coordinate is going to be c. Okay, I hope you followed along with that. Okay, so we do the same thing to find t. We're going to add the two x's together, 2b plus 2a. Divided by 2. And you can see if we factor out the 2, we would get 2 times b plus a over 2. Cancel that. And you're left with the x value is going to be b plus a, or we'll just say a plus b. Oops. The x value is a plus b. Now we add the two y's together. It's going to be 2c plus 0 divided by 2. Get rid of the 0, divide by 2, and you end up with C as the y value. Okay, so now we have enough to do this proof. So the S coordinate is BC, the T coordinate is A plus B over C. So now what we're going to do is find out the slope of the line. And the slope of the line, ST, is going to be the y value minus the y value divided by the x value minus the x value. Okay? So let's just write that down. Slope C minus C is going to be 0. A plus B minus B, can you see that's just going to be A? It doesn't really matter what's down here as long as it's not 0, because 0 divided by anything, the slope is going to be 0. So the slope of this line is 0. Let's do the same thing for line AB, line segment AB. 0 minus 0 is 0. 2a minus 0 is 2a. And again, the slope is going to be 0. If both my slopes are the same, that proves that the lines are parallel. Okay? So that's an example of a proof that you might do with this method. They're going to ask you different ones, but they should all be along kind of the same lines. Superimpose your triangle. Make sure one of the corners is on the origin. And usually you're going to have to find the different coordinates, and then you'll do something with that. Okay, that's it.